Welcome to qnawire.
Due to the behavior of the Moon, the period of the Moon's rotation about its own axis, let's call it period for the spinning of the Moon, is equal to the period of the Moon's rotation about the Earth. Let's call it the orbit. Now let's visualize the problem. So let's say this is Earth and this is the orbit of the Moon, which we are assuming to be circular. And let's call the radius of the orbit to be our orbit, and let's say the Moon is somewhere on the orbit. So let's say this is the Moon and this is the axis of rotation of the Moon. Let me choose another color for that. And the radius of the Moon, let's say that is r of the Moon. Now since the period of the spinning of the Moon and orbiting about the Earth, they are equal, therefore the angular momentum will also be same in both the cases. Sorry, the angular velocity will be same for both the cases. And let's call it omega. And if you are wondering how we arrived at this relation, then remember that t, which is the time period, is equal to 2 pi over the angular velocity. And 2 pi is a constant, therefore if t for any two objects are same, therefore their angular velocities will also be same. Now let's find the ratio of the angular momentum for spinning of the Moon over its orbit around the Earth. Now, using the equation for angular momentum, which is I times omega, we can write this equation to be I spin times omega spin, which is omega, over I orbit times omega orbit, which is also equal to omega. And this gives the ratio to be I spin over I orbit. Now, I spin is just the Moon spinning, the moment of inertia of the Moon spinning about its own axis. So, since the Moon is a sphere, the moment of inertia of the sphere will be equal to 2 by 5 mr square, where r is the radius of the object and here the object is Moon. And to find the moment of inertia of the spinning, we assume that we assume the Moon to be a point mass moving around a circle with the center of the axis to be the Earth. So this moment of inertia will be equal to mass times r square, where the radius is the radius of the orbit of the Moon. So now this equation simplifies to, so since we are considering the mass of the Moon in both the cases, so m cancel out. So we finally arrive at 2 over 5 r over Moon square over r of the radius of the orbit square, r of the orbit square. Now radius of the Moon is 1.74 times 10 to the power 6 meter. Now and radius of the orbit of the Moon around Earth is 384 times 10 to the power 6 meter. Now we solve this equation and we get L spin over L orbit to be equal to 8.21 times 10 to the power minus 6.